What is the most extreme, most powerful, and most mysterious object in the entire universe? It's not a star. It's not a galaxy. It's an object with gravity so powerful that it swallows light itself. A place where the laws of physics as we know them break. We're talking about a black hole. But how is this cosmic monster born? And what would you actually see if you found one? The story of a common black hole begins with the death of a star. Not just any star, like our sun, but a truly massive star. For its entire life, this giant star is in a constant battle with itself. In its core, nuclear fusion smashes atoms together, creating a massive outward explosion of energy. This pressure keeps the star from collapsing under its own immense gravity, maintaining a perfect, stable balance. But this star is a gas guzzler. It burns through its fuel in just a few million years. Eventually, the core runs out of fuel and the fusion stops. In an instant, the outward pressure vanishes. Gravity, which has been waiting all this time, wins the battle catastrophically. The outer layers are thrown into space in one of the most brilliant events in the universe, a supernova. But the core is a different story. With no outward force to stop it, gravity crushes the core down and down and down. It collapses past the point of being a proton or a neutron. It collapses forever. All of that mass, more than 3 times the mass of our entire sun, is crushed into a single point with zero volume and infinite density. This point is called a singularity. A black hole is born. So, a black hole isn't really a hole. It's an incredible amount of mass packed into an incredibly tiny space. This creates its most famous feature, the event horizon. Think of the event horizon as the black hole's surface, but it's not solid. It's the point of no return. It's the precise boundary where the gravity becomes so strong that the escape velocity is faster than the speed of light. If you're outside the event horizon, you can, in theory, escape. But the moment you cross it, there is no coming back. Nothing in the universe, not even light itself, can travel fast enough to pull away. This is why it's black. All light that hits it is trapped, and no light from inside can ever get out. So, does it just look like a black circle? Yes and no. A black hole all by itself, isolated in space, would be completely invisible. But black holes are messy eaters. Their immense gravity pulls in any nearby gas and dust. This material gets trapped in orbit, forming a massive flat structure called an accretion disk. As this material spirals inward, like water down a drain, it gets compressed and heated by friction. It gets so hot, millions of degrees, that it glows brighter than entire galaxies, shining in X-rays and radio waves. So, when we see a black hole, we're not seeing the hole itself. We are seeing this blazing hot disk of material around it. The black hole itself is just a dark shadow in the middle of this glowing ring. And there's one more effect. A black hole's gravity is so intense, it warps the very fabric of space-time. Think of it as a bowling ball on a trampoline. This warping bends any light that passes nearby, an effect called gravitational lensing. This creates bizarre visual distortions. You'd see the light from stars behind the black hole bent and warped around it. You'd even see the light from the back of the accretion disk bent up over the top and bottom, creating a glowing halo. It's one of the most alien-looking sights in the cosmos. Now, for the biggest myth. Black holes are not cosmic vacuum cleaners. They don't just fly around space sucking things up. A black hole's gravity is just like any other object's gravity. If we replaced our sun right now with a black hole of the exact same mass, you know what would happen to Earth? Absolutely nothing. Well, we'd freeze to death. but Earth would keep orbiting the black hole just as it orbits the Sun. You only feel the black hole's extreme weird effects when you get very, very close to the event horizon. And if you did get too close, you'd experience something called spaghettification. The gravity at your feet, being closer to the black hole, would be so much stronger than the gravity at your head that you would be stretched like spaghetti into a long, thin stream of atoms before you even reach the event horizon. It is not a good way to go. Black holes aren't just destroyers. They are a fundamental part of the universe. We now know that supermassive black holes sit at the center of almost every major galaxy, including our own. They are the universe's ultimate engines of recycling. They eat stars, but their energy output also helps regulate the birth of new stars. They are the terrifying, beautiful, and necessary anchors of the cosmos. From the violent death of a single star to the silent, gravitational heart of an entire galaxy, the black hole remains the ultimate puzzle. We hope you learned something today about black holes. Please hit the like button, and subscribing to our channel will give us motivation for making more such videos.